Run HySight. To demonstrate smoothly, we will change the settings in advance. I will explain it sequentially. The program name and version information are displayed at the top left. Click on the letters to check the camera information and library version. The top side contains setting items related to the camera. In imaging, Snap acquires the image only once. Grab acquires images continuously. In acquisition mode, raw images represent raw data captured by the sensor. "512 spectral images appears at the same location. Each row contains information of a different wavelength. Band images are expressed in the form of images for each wavelength band, indicates an image that has been image processed to a height set to the height on the right. In the wavelength range, VIR represents information from 450 to 1700 nanometer. IR represents information from 900 nanometer to 1700 nanometer. If you look at the raw image, you can see that the sensor's height information changes. In the image format, the width can be set to the horizontal width. In the viewer, the maximum width of the AHS-003VIR is fixed to 640. Height is the height setting of the band image, and the maximum height that can be set is 12,000. Pixel format allows you to select information from one pixel. Mono 8, 10, 12, and 14 are supported. For the AHS-003VIR connected in this video, mono 8, 10, 12 settings are possible. In acquisition, exposure time can be used to set the exposure time of the camera. Acquisition rate needs to be set in FPS, which is the number of raw images output per second. In digital and analog, gain is the digital gain value of the output video. Offset allows you to set the offset value of the output video. In filter, you can use the sharpness filter, which enhances the edges of the image. Off, turn off the filter. Low, slightly emphasizes the edges of the image. High means strongly emphasizes the edges of the image. The captured image is displayed in the middle center. Depending on the mouse position, the graph below displays wavelength information for each pixel. You can zoom in and out of the image by operating the mouse wheel. When enlarged beyond a certain percentage, you can check the coordinate and gray level of each pixel. You can register wavelength information by right-clicking on the desired coordinate of the image. In the graph below, each wavelength image can be displayed. The Processing tab on the right has 5 panels. The Layer panel displays thumbnails and wavelength information of the selected RGB. Moving to the desired wavelength and pressing the eye shape, you can apply the selected wavelength range to RGB. The Image Processing tab allows similar color display based on the RGB properties of the layer panel. You can use noise reduction to lower the noise level in your images. This feature is enabled by default. Clicking on an icon in HySight detects the spectral data at the coordinates the mouse is pointing in the displayed image and displays similar colors. Threshold sets the detection condition range. The higher this value, the stricter the detection conditions. Target mode means display coordinates with similar characteristic to the spectral data. Changes the mouse position to a similar color. Pseudo color mode displays all coordinates executed in the register spectrum. In the Trigger Control panel, you can set trigger-related settings appropriate for each condition. You can use the desired condition by selecting the source and active conditions. For example, when using on any edge of line 1 as the acquisition start, select line 1 in source, any edge in activation, and then click the icon. Timed in exposure mode operates as a fixed exposure control. Trigger width exposes for as long as the trigger signal is valid. Line pulse selects the trigger signal to display the pulse width. High means displays the high period of trigger signal. Low means displays the low period of trigger signal. You can make encoder-related setting in the encoder control panel. In source A, Set the source of phase A used by the encoder. In source B, set the source of phase B used by the encoder. In mode, set the trigger pulse output method. For phase, starts counting when the signals of phase 1 and phase B turn low. High resolution sets the A phase and B phase signals to a multiple of 4. Divides the counter value. You can change the values to increase or decrease the image. Frequency displays the encoder frequency. You can save or load images in the image data panel. The Save button saves the currently displayed image. Save All saves the entire captured image in bitmap format. File name is saved in the format of the file name underbar wavelength information underbar BMP. Save NV saves the entire captured image in NV format. The header file of the file name is saved with the HDR extension, and the image data file of the file name is saved with the binary extension. 3 data storage modes are supported. Band separation saves images separated by wavelengths. When saving, 512 images for each wavelength are saved. Band sequencer can save classified images as a single frame. One image containing 512 pieces of data is saved. Band interleaved can save unsorted raw images as single frames. Load all, loads all hyperspectral images captured and saved with this program. You can load more than 8 band images. Load NV can load images data saved in NV format. You can load more than 8 band images. Save CSV spectrum data has been added in the latest version of the viewer. Save CSV spectrum data allows you to save spectrum data in CSV format. Clicking the icon saves the spectrum data of the set area. Data is output as one file per line. If the designated area is large, it may take time to save the data. Overlay displays the range where spectral data is output with a dotted line. Start point X sets the X coordinate of the starting point. Start point Y sets the Y coordinate of the starting point. Endpoint X sets the X coordinate of the endpoint. Endpoint Y sets the Y coordinate of the endpoint. You can set the range with this setting. There is a spectrum graph at the bottom. Displays the mouse cursor or register spectrum data in 2 dimensions. The x-axis is a wavelength value and the y-axis is the luminance value. On the right side is the registered wavelength data. By default, coordinates are registered as names, but this can be changed. Up to 7 wavelength data can be registered. You can change the name of the wavelength with the Rename button. You can change the color of the wavelength with the Change Color button. You can delete registered wavelengths using the Delete button. The white vertical line indicates the selected wavelength band. You can move by left-clicking the mouse. When you right-clicking, 3 options appear. Normalizes the spectrum graph. Register wavelength range can be selected by right-clicking and dragging the mouse to select the desired wavelength range. Afterwards, you can obtain images of the desired wavelengths. Please specify at least 8 bands for the wavelength. This feature is only supported by the AHS-003VIR being demonstrated in this video. Reset wavelength range deletes registered or selected wavelength. Let's look at the data icon on the right side. The trash can shape, delete registered wavelength data. The graph shape saves the spectrum graph registered on the left in bitmap format. The icon below is Save CSV, and you can save it in CSV format. Save the registered spectrum data as a CSV file. This icon below, it is Load CSV, which loads the file saved in Save CSV. The button right is a histogram. After selecting binarization by left-clicking the mouse, a red line will appear at the mouse position. The luminance value is binarized based on the red line. By right-clicking and dragging the mouse, you can specify the range of luminance value. If you click Contrast Emphasis, an image with the luminance value of the selected range emphasized will be displayed in the graphic box. Clicking the mouse wheel clears binarization or contrast enhancement settings. The button left side displays coordinates and field values. Displays frame count and frame rate. Displays the band gain value of the image. Displays wavelength information and band information. Displays the temperature of the camera sensor. Displays the status of application. Information such as ready, image acquisition start, image acquisition stop, overflow, and detection is displayed.